All right, thanks, Tim. Now let's look at some possibilities for large language models in DI products. First, I want to go into a little bit of background. ChatGPT, Google Bard, Claude, and these other similar AIs, they use a large language model, or LLM. And a large language model has one simple goal, which is you feed it some text, and it just makes a guess at what the next word should be. This is a game that my kids like to play, where they sit around the table and each one of them comes up with a word, and they try to put together a story without, working together like that. It doesn't sound like much, but these models have been trained on so much data, and the models themselves, the network in the model is so large that they have emergent properties that are surprising and make it seem like they're thinking, which they're not. For example, if you've trained the model on a lot of English text, and then you separately train it on a bunch of French text, and you merge those models together, it's able to translate between the two without ever actually being trained on the translation task. So it seems as if it understands the language. Now, the short-term memory of an LLM is just the prompt that you've given it. You're going to feed it some text, and it will guess what the next word should be. That prompt is limited in size, and so you can have a conversation with it, but eventually you're going to hit that limit, and the start of your conversation will be forgotten. The long-term memory of an LLM is the training data that it was trained on. This has been text from all over the internet, and that data is fixed into the model and unchanging during your conversation. So it has no way to move new information into its long-term memory. It also doesn't really hold a thought longer than it takes to spit out one word, right? If it spits out a single word and then you ask it what's the next word, it starts all over again. So it's an interesting little problem. The resulting output is actually pretty convincing, though, and as a tool, it's very good for language processing tasks. Now, at the Cambridge lab at DI, we've been doing some experiments with this technology and trying it out on a number of tasks, some of which I've listed here. We've had mixed results. For some things, it seems to do pretty well, and for other things, not so well. So for summarizing text, for example, it works very well. It's a great tool for such a thing. But for data-related tasks or complex tasks, we're starting to see that it has some real problems. The second to the bottom here, describing metadata, I'm interested in doing some research on that one because that is something where it's a mix between data and text. We have text in the measure factory definition config file about measure definitions and descriptions and references. That text can be fed into these models. The model can be used to summarize that text or to answer questions about it sometimes. But the last one here I want to dig into some more detail on in particular. The idea here is to translate a human question into a SQL statement. What we would like to do is be able to take a human question and turn it into a diver query, something that we can plug into our system and run it. But these models are not trained on diver scripts, and so we find the next best thing, which is SQL, which they do understand. And the concept of taking a human question and turning it into a SQL query is right in the wheelhouse of these large language models because it's effectively a text translation task. Now, it almost works, but there are a lot of hurdles to overcome. So one of the problems is you need to describe the data structures that you're able to query very thoroughly, or else it will tend to misunderstand the question. For example, if you have a column named units, you have to explain to the model before the human question comes in what units means and what is units related to, what is the relationship between these columns, and give it some context. Otherwise, it will tend to misunderstand questions because humans don't always ask questions in a very rigid query-like manner. It's pretty good at producing valid SQL, but the problem is that SQL as a language isn't very standardized, and so there are a lot of different database vendors and different variations of SQL, and these models have been trained on a lot, and so sometimes they'll just output SQL that doesn't fit a particular database. That means that our software to process it has to understand all of them, or have some way to fall back if it doesn't understand the query. Now, when it comes to asking it specific questions, it's unreliable for anything that's not a really simple question, right? You can ask it what the total of some column is between this date and this date. And as long as it can figure out which date column to use, it does a pretty good job at figuring out what the SQL query should be. But for more complex questions, it's really not very good at producing good results. Now, I think there's still a lot of promise here, right? Lots of people are working on this specific problem, and the technology is still young. So I think we've got a lot of movement possible in the future here. In particular, one of the things that people are looking at is taking the output, the SQL query that it produced, and feeding it back to the LLM, basically asking it, how well did you do at answering this question? And sometimes it can identify problems. So summarizing what the lab has found when it comes to large language models, they're good at language tasks. They're good at translation, they're good at summarization, and assisting with writing. But they're bad at data processing and analytics, and they're unreliable for automation and things like writing scripts. In business intelligence, you want answers you can count on, and these models are simply not ready for that. So that's why, for the near future, DI is planning to focus on algorithmic approaches. For example, assisted analytics, which is our tool for automating the process of looking at different data points and seeing if there are any outliers that might be of interest. We're looking at regression analysis using R and Python, which can be integrated into our tools and used to do AI-like tasks. There are also formulaic analytics. We're talking about things like LACE scoring or industry-specific formulas that you can apply to your data and try to find insight. And also other AI-enabled applications. An example there might be predictive analytics, where you can build a model from the data and then use that model to look at. We're definitely going to keep looking at these new chatbots, ChatGPT and so on, and the new technology that backs them. And where it makes sense, we're definitely going to make use of these things. And with that, I'd like to hand it back to Kathy and Lieven.